Right, so this says the table summarizes the results of 982 pedestrian deaths that were caused by automobile accidents. If one of the pedestrian deaths is randomly selected, find the probability the driver was not intoxicated, but the pedestrian was. So we have two columns involving pedestrians, yes and no. Were they intoxicated? And we have two rows involving drivers being intoxicated, yes or no. So we're looking for the group out of the total 982 that satisfies both of these things. The driver was not intoxicated, so that's going to be this row. Driver's intoxicated, no. But the pedestrian was. So that's the pedestrian is intoxicated. So that's where they overlap. This column and this row. So this is going to be 218 out of 982. We get rounded to one decimal place to be 22.2. Okay. Same idea here. There's 984 pedestrians. It says if one of the pedestrians is randomly selected, find the probability the pedestrian was intoxicated or the driver was intoxicated. So that's going to involve our OR formula. So that means we have the probability of A or B is equal to the probability of A plus the probability of B. This is from the video and notes, minus the probability of A and B. So this is going to be the probability that the pedestrian was intoxicated. So that's just the probability of A. Probability the pedestrian was intoxicated is both of these added together. 43 plus 280 is 323 out of the total 984. Plus probability of the second thing, which is that the driver was intoxicated. That's going to be both of these, 43 and 82. So that is 125 over 984 minus the probability of both. So look, what I actually did here was I said, all right, probability of pedestrians intoxicated is these two groups. Probability of the drivers intoxicated is these two groups. So you see that when doing that, I counted this group twice, the 43, which is the probability of both, the pedestrian and the driver's intoxicated. So I have to subtract that. That's 43 out of 984. So you can actually just put this whole thing into the calculator just the way it's written. Minus 43 divided by 984. So we get 0.4115 or 41.2. And then this is, okay, same idea, 975 pedestrian deaths. Two different deaths are randomly selected. Find the probability that both involved pedestrians that were intoxicated. So this is just going to be probability that a pedestrian was intoxicated. We'll just say PI times the probability the second pedestrian was intoxicated. So the probability the first pedestrian was intoxicated is just going to be these two groups out of the total. 289 plus 49, just to be extra careful. 338 out of 975. And the thing to remember here is when you find the probability of the second thing, you always assume you got the thing you wanted the first time around. So this is the probability of picking a second person from that same group, assuming we picked a person from that group in the first poll. So if I did do that, that means there's only 337 cases left out of a total of 974. Subtract one from the top and the bottom. So I get 338 divided by 975 times 337 divided by 974. 11.99, or to one decimal place. This 9 is going to round that 9 up. So this is actually going to be 12.0%. And this last one says a hacker is trying to guess someone's password. The hacker knows somehow that the password is 11 characters long, that each character is either a lowercase letter, an uppercase letter, or a numerical digit. Assume the hacker makes random guesses. What is the probability that the hacker guesses the password on the first try? Well, how many different passwords are there? If it's 11 characters long, I'm going to draw out these spaces that represent the characters. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. How many choices does the person have for this character in the password? Well, it can be any of the lowercase letters, that's 26. Any of the uppercase letters, that's 26 more possibilities. Any of the 10 digits, 0 through 9, so there's 10 choices there. So this is going to be 26 plus 26 plus 10, that's 52 plus 10, that's 62. The person who created the password had 62 choices for each character in the password. So this is going to be 62 for the first character, 62 for the second, times dot, 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 all the way to the end, which is going to be 62 to the 11th power. That's a huge number of passwords. So it's one of those. Their password is one of these 62 to the 11th power. So if I said, all right, what's the chances they guess it on the first try? It's going to be 1 out of that number, which they want us to enter our answer as a decimal or a fraction. Let's see here. That's scientific notation. This is basically saying, since this is 1.92 times 10 to the negative 20, that means literally take this decimal place and move it 20 places to the left. So that's going to be a decimal and then 19 zeros and then a 1 and a 9. So I would think, unless it told you to enter this as scientific notation, that you should just enter your answer as 0. Or if they said enter it in scientific notation, you would say 1.92 times 10 to the negative 20. Let's see what the computer has. 1.92 times 10. So they put it in a scientific notation. It might still give you credit if you put in 0, but they want you to write it as the scientific notation.